Hi, in this video, we're going to be talking about the Cartesian plane, plotting points on the Cartesian plane, and finding the distance between 2 points. And this video will be part of a larger series called the coordinate geometry, where we'll be looking at the first topic mentioned in this video, the Cartesian plane, how to plot points on the Cartesian plane, and also finding distance between the 2 points on the Cartesian plane. In the second video we'll be releasing on coordinate geometry, we'll be looking at the midpoint of a line segment, how to find the midpoint of a line segment. The third video we'll be looking at the division of a line in a given ratio, the internal division of a line in a given ratio. Then after that, we'll look at the external division of a line also in a given ratio. Then we'll move on to talking about the gradient of a line, after which we'll talk about the equation of a straight line. And then we'll look at the parallel and perpendicular lines, that conditions for lines to be parallel, conditions for lines to be perpendicular. Then lastly, we'll talk about the non-linear transformation and also the area of triangles and quadrilaterals. So basically what we're doing is we want to talk about everything coordinate geometry in this series. So do well to stay tuned. Now, what does the Cartesian plane, what does it mean? So the Cartesian plane is just a way of describing a point located in space. When we locate points in space and want to describe such point or the coordinate of such point, one of the ways or means in which you can do that is by making use of the Cartesian plane. And Cartesian plane, or another word, or another name rather, for the Cartesian plane can be called the rectangular coordinate system. So what it simply means is, if you've seen a graph before now, when you're plotting your graph, you have the positive y-axis, you have the positive x-axis, you also have the negative x-axis, and lastly, the negative y-axis. Now, why we call this the Cartesian plane is because we can use it to describe any point that can be located anywhere, whether in the first part or the first quadrant, that is the topmost right corner you're seeing here, where y and x is positive. Now, if you don't know why y and x is positive, you don't need to bother about that for now. We'll talk about that extensively when we start taking questions. But for now, know that we have 4 quadrants. That is, this is number 1, this is number 2, this is number 3, and this is number 4. So no matter where it is, I'm locating a point. I can describe the point successfully. That's why we refer to this as the Cartesian plane or the rectangular coordinate system. Now, any point that is being located on the x-axis, whether the positive x-axis or the negative x-axis, is being referred to as the abscissa. Abscissa on the screen. So any point you locate on the positive x-axis or negative x-axis, we always refer to it as the abscissa. While the ones we represent on the y-axis, we call them the ordinates or the unit. Now, since this is a pure mathematical class, names like abscissa ordinates, we're not concerned about it. That is, you will be quizzed on what's the name of a point located on the y-axis or x-axis is called. You will be called that. But why did I mention this? This is to tell you that before we can describe any point, let's say I have a point here. If I can describe any point in the Cartesian plane, I need the abscissa, then followed by the ordinate. The abscissa will always come first, while the ordinate comes second. And they have to be written in an ordered pair. That is, we have something like this. So let's say AB represents the abscissa, YOR represents the ordinate. Of course, we don't use AB, we don't use OR. Instead, we use X and Y. Now, depending on where the point is located at, if the point is located in the first quadrant, both X and Y will carry a positive sign. If the point is located in the first quadrant, like I said, both X and Y will carry a positive sign. If the point is located in the second quadrant, then the abscissa will carry a negative sign, while the ordinate will carry a positive sign. For the second quadrant, if the point is located there, by saying the abscissa, that is x value, will be negative, while the y value would be positive. Now, if the point is located in the third quadrant, then both the abscissa and the ordinate would be negative. If the point is located in the third quadrant, the abscissa, the ordinate would be negative, or simply put, the x value and y value would be negative. And finally, if the point is located in the fourth quadrant, then the abscissa will be positive, while the ordinate will be negative. So these are sign conventions that you want to be familiar with, as this will help you a lot in both for those taking maths and also physics. All right, this said, let's try to put this into effective use. So I'm going to be cleaning the screen now, and then we'll be trying to locate different set of points after calibrating our XY plane or Cartesian plane or the rectangular coordinate system. Whichever name they use or the textbooks are using, they mean the same thing. All right, so let me call the points where the x-axis, that is this x plane, and the y plane meet. Let me call it the origin or the reference point. So this will be my 0. So let's say this is 1, this is 2, this is 3, this is 4, this is 5, 6. Okay, 1, 2, 3, 4. This is -1, This is negative 2, this is negative 3, this is negative 4, and this is negative 1, this is negative 2, this is negative 3, this is negative 4. So I'm going to be placing 4 points each on the 4 quadrants that we have here, and we're going to be trying to locate each set of points. So I'm going to do the first one, and you're free to pause the video to get the remaining 3. It's going to be quite easy, so I hope we can all try to follow. Okay, so let's look at our first point at this junction. Let's look at our second point at this junction. Let's look at our third point at this junction, and let's look at our fourth point, let's say, at this junction. Okay, so the question is to try and describe the point. So let me call this A, let me call this B, let me call this C, and let me call this D. So if I were to describe point A, what will I do? I simply need to get the abscissal, the value, and then the ordinate, or the X and then the Y. Now, if you look at this point here, you see that this point is lying on 4, isn't it? Of course, this is not drawn to scale, but let's just imagine it is lying exactly on 4. And if you look at the y-axis too, this point is resting on 3, isn't it? So definitely, it must mean that for me to describe my point A in an ordered pair, then I'll simply write 4, 3, and that's all. I've successfully described this point A in the abscissal force and then the ordinate. But one more thing we need to note, you can see that the value or the sign of X or the sign of the abscissal is positive, while the sign of the ordinate also is positive. I mean, we said that, isn't it? That in first quadrant, both the abscissal and the ordinate have positive values. Now, for point B, now how do we locate point B? What will be the coordinates for point B? Again, get the X value first. The X value, you can see this is lying on -1, so I can write -1 here, comma, and this is lying on +2 on the y-axis. So B, describing point B, I have -1, 2. For point C is lying on -4 and also -2. So point C, I can see my C would be -2, -4. Why for point D? Point D, you can say this is +5 on the x-axis and -3 on the y-axis. So D here would be given as 5, -3. So this is how we describe points in a Cartesian plane, and also how we plot points in a Cartesian plane. I hope this concept is quite clear. Now, I want to look at how to find the distance between 2 points. So let's say we have, this is point A, and then I'm having another point here, and then I want to find the distance between these 2 points. So what do I need to do? First of all, I'm going to clear this, and then we can look at how to derive the equation or the formula for finding the distance between 2 points. So let's say we're given this diagram. We have 2 points, A and B, and the coordinates of A were given to be x1, y1. The coordinates of B were given to be x2, y2. So for this coordinates, what it simply means is this A is located somewhere on the x-axis, is also located somewhere on the y-axis, like this. And then also for B, located somewhere on the x-axis and located somewhere also on the y-axis. Now we want to find the distance between these 2 points. Since these 2 points are represented on the Cartesian plane, then we can apply what's it called? Pythagoras theorem. And what does Pythagoras theorem states? Pythagoras theorem, when we have the right angle triangle, we know this should be this is the longest side C, this is the adjacent side A, and then this is the opposite side. We know that C squared would be equal to A squared plus O squared, isn't it? So we want to apply the same logic here. But firstly, if we're saying this side here is x1, remember, before we can describe the point, we need its x coordinate, we also need its y coordinate. So the x coordinate of point A is given as x1, the y coordinate of point A is given as y1. The x coordinate of point B is given as x2. The y coordinate of point B is given as y2. Okay. Now we can now try to apply a Pythagoras theorem by filling in the different sides of this triangle. Remember, we're looking for the distance between this point here and this point. So let me call this D for distance. Now let's look at this. If this is my origin, from my origin to where point B, or the projection of point B on the x-axis, should be x2. What it means is, if I were to take a ruler, just measure from 0 to this point here, it will be x2, isn't it? Now, if I were to take the same ruler and measure from this point, that is the origin, to where A is, it will be x1. So that means in between will simply have to be x2 minus x1. I hope this is okay and clear. X2 minus x1. Okay, if that is clear, now if I do the same thing on the y-axis, if from the origin here to where point B is given as y2, and from the origin again to where point A is given as y1. So it must mean that this gap in between, that is the difference between this point B and point A, vertically now, should simply be y2 minus y1. So I can put this in brackets. Now that I've gotten the different sides of my triangle, I can now apply my Pythagoras theorem. So I'll simply say d squared, that is the distance squared, should be equal to x2 minus x1. Okay, so let's write that properly. X2 minus x1, everything squared, plus y2 minus y1, again, everything squared. But since we're looking for the distance, then definitely we need to find the square root of this. To find the square root of this, we simply have d would be equal to the square root of this, x2 minus x1, everything squared, plus y2 minus y1, everything also squared. So this is the formula we want to use to find the distance between 2 points. Now let's just take a quick example. So let's say we're given point A. Let point A be 2 comma minus 3, and point B be equal to let's say 4 comma 9. And then we have to find the distance. Find the distance between A, B. So what do you think this will be? Now you must note that you must carry out your what's it called? Subtract first, then square before you add. Don't add first before you now try squaring. You might end up with a different answer. What do I mean? By the time I press this in my calculator, or just apply my formula first. If this is point A, this is point B. So I can say this is my x2, and then definitely this will be my y2, and then this is my x1, this will be my y1. So what do I want to do? Again, x2 minus x1. So that's 4 minus 2. Again, everything squared, plus 9 minus 3. You can see that the coordinate of y1 is negative 3. And then since the formula is y2 minus y1, so we apply the negative sign twice. So this becomes 9 plus 3. Okay, so distance between A, B would be equal to 4 minus 2, that's 2 squared, plus 9 plus 3, that is 12 squared. And 2 squared is 4. 12 squared is 144. And then we have our distance should be equal to 4 plus 144, that's square root of 148. So I hope this is quite clear. This is how we first of all plot points on a Cartesian plane, and also find the distance between these 2 points that has been plotted. All right, so thank you for watching. In the next video, we'll be talking about the midpoint of a line segment.